Hey guys, in the last couple of weeks, we have been working with the first thing that we did was simplifying and rational expressions. We learned how to multiply, divide, add, and subtract them. So, okay, now we're going to combine all of this. That we're going to work with complex fraction. What is a complex fraction? It's a fraction in which your numerator contains another fraction, and your denominator is another fraction. I would say fraction of another fraction. And how do we solve that? I told you to work with just the numerator separately, right? Right? We're gonna work just with my numerator. Let's copy this expression and we're gonna try to solve it. This is a little bit big, but at the end you're gonna see that it's gonna be pretty simple. Okay, let's try to copy that. And
The last number is the 4, right? It's a 4 or 9.
I don't remember, to be honest. Let me see. I think, I don't know if is it a 9 or a 4. I think it is 4. Let's leave it like a 4. Okay, I'm going to erase that. It's a 4. Okay, I'm going to put a 4 here. Okay, it's a 4. Okay. It's a 4. Okay, that's it. Okay, what do we have to do, guys? We're going to focus ourselves in the numerator. Okay, let's try to work on that. Okay, what do we have, guys? We have the denominator totally different, right? We have a minus.
Cannot do anything.
Okay, but I need to add them. Okay, how would I add them, guys? I need to find out the least common denominator, right? Can someone help me? What is going to be?
A minus 1 and A minus 6.
A minus 1 and A minus 6.
Thank you. I need to include all the expression that I have in my denominators and A minus 6. That is that. Okay, let's check it out again, guys. I need to make sure that I contain all the expression that I got in each denominator separately. Okay, I have A minus 1 is here. A minus 6 is here. Okay, it's done, guys. Okay, now we're going to use the same idea that we used when we were adding or subtracting fractions with different denominators, unlike denominators. So we're going to divide by this and we're going to
multiply by denominator.
Excellent. Thank you for helping me. Okay, let's do it, guys. And now you're able to do this mentally. Okay, this divided by this expression.
A minus 6.
This is going to be canceled.
2.
Because it's 1. Okay, A minus 6. Okay, 2 times. Okay, I'm going to put the 2 first. 2
times A minus 6.
Minus 6. 2 times A minus 6. Plus, let's continue, guys. And let's divide the second expression. Let's work with this. This
A minus 1.
Okay, this is going to be canceled. This divided by this is just 1. Okay, A minus 1 times 3. Or, I could say 3 times
3 times A minus 6.
A minus 1. Thank you. That's it, guys. Okay, I just worked with the first expressions. Okay, let's work with the denominators. This is a little bit huge, but we're going to work with this. Okay, let's see what we got here, guys. Again, we have different denominators, right? Okay, we're going to use...
Only copy them.
Okay, we want to copy, that's the least common denominator, A minus 1, A minus 1 times A minus 4. Okay, that's it. And now we're going to use the same idea. We're going to divide, and we're going to try to find the numerators. Okay, let's divide this by this, guys.
A minus 4.
Okay, I can. Okay, I'm going to get A minus 4. Excellent. A minus 4. Okay.
3 times A minus 4.
Yeah. Copy the 3 first. 3 times A minus 4. A minus 4. That's it. It doesn't look like a 4, right? Let me see. I don't know what's 4. And let's continue. Plus. Okay, plus.
1 times A minus
1 times A minus 1.
Excellent. This is going to be canceled. This is equals to 1. A minus 1 times 1. This is the same, right? A minus 1. Okay, let's put it. A minus 1. That's it, guys. Okay, this is what we got. And now, guys, as I told you yesterday, we can use the year method, but before doing that, guys, let's try to simplify as much as we can, because if we don't do it, what's going to happen? We're going to get the same answer at the end, but we're going to work a little bit harder. So that's why let's try to simplify. Let's focus on this expression. Can we simplify something?
multiply.
Multiply.
Triple purple.
Okay, we're going to copy all of that again, and we're going to try to simplify it. Okay, let's copy all of that. Okay, let me see, equals. Okay, let's work with this. Okay, using the distributive property, 2 times A minus 2A
2A minus 12
plus 12
plus 3A
Plus
3A
3A
minus 3.
3 minus 3. Excellent. Over. Okay, in this, there's can do not multiply.
Sir,
Tell us, mister.
I'm proud about these students. Yes, I'm sorry I had to leave because I have classes at 8.
Okay.
Hey, students, my respect for you. You got it. Okay, bye-bye. It was a pleasure to see you.
I miss
Bye.
Bye, everybody. I'm proud
Bye.
about you.
you. Always gonna be welcome to come back.
Yeah, just send me the link. Bye-bye, people.
Sir, thank you, thank you. Okay, good pleasure to have Mr. Dia with us. Let's continue, guys. This, take a look. This is actually factor. Okay, I leave it like that. Okay, I'm looking for factors. Okay, let's copy a minus one times a minus 6, right? Okay, over. Okay, let's see this expression, guys. Can we simplify? Can we do something here, guys? Of course, right? We can use the distributive property for this. What is going to be
3a minus 12.
minus 12? Okay, plus this
Plus a minus 4.
right? 4 or 1? It was what's that? A minus
1.
a minus 1. It was 1. Okay, yeah, a minus 1. And this denominator, guys, let us copy it again. Okay, we're gonna copy that. Okay, we're gonna copy that because it's in form. Okay, that is going to be equals to a minus 1, right? A minus 1 times a minus 4.
A minus 4.
Thank you, thank you. Okay, we have this, guys. Now,
Now group the common.
excellent. Yeah, the common terms, right? The like terms. Okay, términos semejantes. We're gonna work with the like terms. Take a look that you have 2 apples here and you have 3 apples. Guys, instead of, wait, if you wanna be a little bit neat, you have to copy this again and try to simplify. What I'm gonna do, okay, what I'm gonna do, and it doesn't mean that you have to do it like me, but if you wanna be a little bit lazy, okay, let's simplify this, okay. What are we gonna get out of this, guys? 2 apples,
5a.
5 apple.
5 apple, 5a, and the numbers, constant term. You have
Negative 15.
3, negative 15,
Negative 15.
15. Okay, expression for this. I'm gonna cross this out, okay? Instead of this, all of these guys is equivalent to this. I just rewrite it. And let's go to the denominator. Okay, let's see what we got here. Okay, what we got.
3a plus a, 4a.
Okay, this is going to be, okay, 4a, right? 4a. And the numbers 3,
Minus negative 13.
negative 13. Okay, negative 13. Okay, I'm gonna cross this out because I don't need it. This is my new expression. Now, guys, okay, I think this is a little bit simpler. Now we can use the year method. Okay, let's try to use that. Okay, I'm gonna multiply the first one and times the last one. Okay, let's see what we're gonna move on a little bit here. And let's see, guys, help me. The first one times this denominator.
But we cannot do something with the first expression. 5a minus 15 with common factor.
Exactly, we can do something, but it's not gonna be that helpful. If you wanna do it, do it. Okay, of course, thank you that you noticed that. Because we have a common factor 5 and 15. Okay, let's do it. Okay, you can do it here or at the end. Okay, let's do it. You notice it? Okay, this is equals to what? 5a minus 3, right? I just factored the 5. That is the greatest common factor. 5 times 8, 5a. 5 times negative 3 is negative 15. Okay, this is going to be my last expression. Okay, this one. Great, Angie. That was impressive. Okay, let's see. What is my first term? Can you tell it out, please?
5a minus 3.
Multiplying what, guys?
4a minus 13.
It is. Oh my gosh. Oh my gosh.
A minus 1.
And I opened the text. Sorry, guys. I don't know what I did. Okay, let's continue. Okay, the first one. Okay, this one multiplying the last one. Okay, this
A minus 1.
a
A minus 1 and a minus 4.
a minus 4. A minus 4. All right. Okay, this is a 4, guys. I'm a little bit clumsy today, guys. I don't know what's going on. Okay, over. Okay, let's multiply the middle terms. Okay, let's go.
A minus 1, a minus 6.
Okay, a minus 1 multiplying a 6 multiplying
4a minus 13.
minus 13. The middle terms, right? Okay, this is what I got, guys. Okay, so far I need to factor something. If I
We cancel.
okay, what I can I cancel?
A minus 1.
A minus 1. Okay, okay, yes, a minus 1 and a minus 1 is equals to 1. What else?
Just that.
Just that, right? Okay, this one's not, that's, okay, let's copy that, that's it. Okay, 5, a minus 3, multiplying a minus 4, right? Over, what else? The denominator is gonna be a minus 6, multiply
4A minus 13.
a minus 13, okay? And you leave it like this, guys. You don't need to simplify that because you are factoring, okay? This isn't a factor way. Take a look that this is simplified. If you don't simplify before using the IRT method, you're gonna get something here a little bit big and something
I
weird.
want you to solve one of the worksheet.
Okay, of course, I'm gonna solve one of them. Okay, let's see this complex fraction. Okay, how can we solve it? Okay, first of all, guys, work separately. Okay, that's the first thing that you're gonna do. Work separately and try to factor. Okay, that's the thing that you're gonna do. Okay, let's see the denominator. Okay, in this denominator, guys, we have this fraction and this is not a fraction. How can I turn this one?
One.
One down. 1 as a denominator.
Just adding 1 because the 1 is the unit. Okay, it's not going to change the original value. 1 divided by 1 is the same one. Okay, this is a fraction. Okay, this is fraction, guys, with the different denominators, unlike denominators. Okay, what I'm gonna do, I'm gonna find the least common denominator. Okay, let's work with that. This, and what is the least common denominator of 1 and 1? The numbers. 1. 1. Of course. And I include the variables. My variable in this case is x. That is the greatest one. I just included. Now let's do the same procedure, guys. This divided by this and multiplying by the numerator. X divided by 1. X divided by 1. X, right? Is it
X.
X? Multiplying the numerator. What is my numerator equals to? 1. X times 1, guys, is 1x. If you want to put it at 1, put it. I don't need it. I don't like how it looks like. Okay, I'm going to let the x minus, okay, minus. This x, guys, divided by x. Okay, something divided by the same is 1. 1 times 2.
2.
2. Excellent. Over. Tell me.
When when he saw 1 before the x, I was like, when I practiced with my sister, because last year when we was in that, I was a disaster. So she tried to explain me, and I was like, there is missing a 1. Where, she said, before the x. No, even though you don't, there is not in the equation a 1, there is always an imaginary 1 in before every variable.
Exactly.
So like that, understand that.
Oh, great. Good point. Whenever, yes, that's a problem because some students say, which value do I have here? What is the coefficient for the variable? I have nothing, and that is 0. No, this is 1. Every single variable stands for 1. If it doesn't have any different number than 1, it's going to be 1. And good point. Okay,
Mister,
tell me.
I'm gonna turn off my camera only 1 minute. I need to do something.
Okay, we're going to kill you, but do it. Okay, let's continue. We have already simplified my numerator. Let's try to work with my denominator. Again, this is a fraction. This is not a fraction. And we have to use the imaginary one. I don't like to use imaginary, guys, because you already have the sense of what an imaginary numbers mean, the complex numbers, right? That's why I don't say imaginary units, but you understand it like that. Okay, let's try to do this one. Again, guys, the different denominators, unlike denominators. Okay, we need to find the least common denominators of this.
9.
9.
9 and 1. What is the least common denominator? Multiple of 9, 18, 27. 1, 2, 3, 4, 5, 9. 9 is going to be, right? Okay, it's going to be 9. Okay, let's put it. 9. What about the variables? I need to include all the variables. Okay, I have an x. Thank you. And let's do the same procedure. This divided by this. Okay, I'm going to repeat that, guys. This divided by this and multiply by this. 9x divided by 1.
9.
9x. Okay, 9x. Okay, sorry. Let me copy that again. 9x. Multiplying my numerator. What is my numerator equals to?
X. So we can write 9 to x squared.
Guys, if you are able to do it like that, do it. Okay, I'm not going to stop doing that, but please don't abuse of your abilities. Okay, be careful because sometimes it's better to recover it and solve it. You might be mistaken at the end, but be careful. But if you want to do it, do it. Like this it's really handleable. Okay, plus, I repeat, 9 divided by 1 is 9x. Multiplying x, 9x squared. 9x divided by 9x, the same quantity, 1 times 4, guys, my numerator,
4.
4. And that's it. Okay, this is what I got, guys.
Not 4x.
Okay,
No.
this is 1. Okay, 1 times 4, 4. Now, guys, let's see if we can factor, simplify, add, or whatever you have to do here, guys, before using the year method. This x minus 2, nothing I can do. X minus 2, neither. X squared, which number is this? I don't even remember. It's 9, right?
9.
They're different. X squared, no, guys, there is nothing we can do, okay? But simplify this, okay? Let's do it. This quantity multiplying ix, okay? Let's copy it. X squared, x minus 2. Take a look, I'm really clumsy today, guys. X minus 2 multiplying the denominator, that is 9x, over what, guys? The middle terms.
X times 9x squared plus 4.
9x squared plus 4. Okay, let's see if we can factor something, simplify something here. Okay, I have this.
We cannot cancel the 9x and 9x squared, right? Because it's the other 9x squared is joined with the 4, right?
Yes, it's adding the other quantity. You can do that. Okay, good point. Okay, it looks a
But we can cancel the x of
X-
9x and x, right?
take a look, multiplying. Okay, multiply.
Yes, but we can cancel the x.
Yes.
Mister,
You tell me.
in that Angie said that you can cancel one number by alone when it's in another equation.
Mm-hmm.
My sister teach me that that equation is like a family,
Mm-hmm.
and the 9 is like, for example, the father or the mother, and it's like, it's in case of you're like being a lover there, so you can just separate the family just like that, so you can take a number out of an equation just because of cancel. And I was like,
That was a great idea. I actually think about numbers in a crazy way. Do you remember when I explained to you that the what is that? Minus times minus is positive, just like that. I use an example related to a relationship, but that one about the family was really great. Great idea. It works like that. You can separate like that. Okay, let me explain that in a more formal way. I'm gonna teach you that again. Okay, let us copy this, guys. What I'm gonna get, guys, that is the only thing that I can cancel, right? Guys, can I cancel something else? I think I can't, right? Okay, let's copy what we're gonna get, guys. That x minus 2. This 9, guys, I'm gonna put it at the beginning as a coefficient, 9 times that, over what I'm gonna get in my denominator, 9x squared plus 4. Okay, this is my denominator. That's the answer, guys.
Let's solve a question that have to square, because there are some ones that have x squared and y squared and things like that.
No problem. We're gonna do. Okay, we have this complex fraction, and let's see how can we simplify it. Okay, first of all, guys, let's focus in your first numerator, because you have two, the fraction, this complex fraction is fraction of another fraction. Okay, let's focus on this first part. How would you solve this? Okay, first of all, let's see what we have. This over this. Okay, guys, this is something good because you only have one denominator. Simple. But what about the numerator? Is there something you gotta do, guys? Or you have on your...
no, because there are different variables.
Mm-hmm. There are different variables, but what do you get to see here? I'm gonna give you the hint.
Common factor.
Difference of a square.
Okay, 4 is a perfect square. 2 times 2. X squared, is it? X times x. Y squared is a perfect square. X, y times y. And minus difference of
Squares.
X. And let's do it. Okay, let's factor that. Okay, that's the first thing that you gotta do, guys. You gotta factor as much as you can. Okay, let's try to factor this. How would you factor 2, guys? As a perfect square. 2 times 2, right? 2 times 2, you get 4. How would you factor x squared, guys?
X.
X and
X
x and
and
how would you factor y squared?
y and y.
Y
And have to be one positive and one negative, right?
is the same idea. One positive is different of a square, and one is negative. That's it. Over. Okay, let's go. Let's go over what, guys? over this x minus xy. That there's nothing I can do but copy that. Okay, xy over again. Okay, now it's time to work with my denominator. Okay, what do we have here? We have a subtraction with different denominator.
We copy
Okay,
yx,
okay, my
the
list.
denominator.
Okay, this line is awful. Okay, the common denominator, I need to include the numbers 1 and 1. Okay, I don't need it. I need to include all my variables.
Yx.
xy or yx is the same. Okay, yx. And
So 2x.
this divided by this. Okay, let's do it, guys.
It's gonna be 2x.
Okay, x
Y.
by y, I cancel that y. I just got x times 2, 2x. Thank you.
2x
X minus
minus
Y.
is divided by this minus
y.
y. That's it, guys. Okay, now before using the EAR method, let's try to simplify something. Let's see if something can be
We
or not. Okay, if everything is as
no, because we can cancel after the EAR method.
okay, let's see. This, guys, is a factor. Okay, it's even better when you have factor. This is a single term. This is 2x minus y. There's nothing you can do. X minus y. Okay, guys, I think we're ready to use the EAR method. Okay, let's try to use that. Okay, this multiplying this. What is that equals to? 2x plus y, the numerator, multiplying 2x minus y over n over, okay, sorry, I'm forgetting something. Okay, let me get back to this. Okay, y, and multiplying what, guys? The
Y.
xy, okay, was forgetting that, okay. Xy over, now yes, over this, the middle terms, okay, this times this. Okay, what is that equals to, guys? Xy times x.
xy times 2x minus y.
Okay, times 2. Okay, I'm copying it wrong. Okay, 2x minus y. Okay, guys, this is
Now we cancel xy and 2x minus y.
okay. That's it. I really love when we get to cancel something. Okay, in this case, I can cancel 2x minus y. This is equals to 1. X
Next Y.
and xy. What I'm gonna get?
2x plus y
2x plus
over
y.
1.
Over 1.
Over 1. We don't need it. We don't actually need it. Okay, 2x minus 2x plus y. Take a look at this huge complex fraction. At the beginning was a little bit tough. Now, guys, it's just 2x plus 1. Pretty simple.
Let's hurry.
Okay, how can we solve it, guys? The first thing, okay. Oh, this negative, guys. These negatives are pissing me off. Okay, take a look at the 2, guys. The 2 is a normal number. Okay, I'm going to copy 2. Okay, I'm going to copy 2. What is going to happen, guys, with this negative exponent? How can I get rid of that?
We pass A
A to
to
the
the denominator.
positive, right? Okay, let's continue with the other one, okay? This, take a look that this is the whole expression is to the negative 1, okay? I need to move all the whole expression to the denominator, 2a. Okay, now it's positive. And which number I'm gonna need in my numerator?
1.
Over, okay, let's see that here the idea, a to the negative 1 power is 1 over a to the first power positive plus this. Be careful with this, guys. Take a look at the 2, guys. The 2 is not negative, okay? You're just gonna copy it. What is negative? Just a minus 1, okay? That you only need to, the one that you need to move, a to the positive 1. And this is the new expression, guys, okay? Having this expression, let's try to simplify. Okay, let's try to simplify this. Okay, how would you do it, guys?
2a to the second power.
2a, okay, 2a. This is my, the 2 is the common, the least common.
A.
And the variable, a.
A.
The greater one is a, okay. This divided by this. 2 divided,
2 times 2, 4.
okay, 2 times 2, 4. Okay, 4 in the numerator plus this divided by this. 2a divided by 2a, guys.
Just gonna be 1.
Okay,
1.
excellent. What about this, guys? A. What is the least common? Oh, they're the same, right? Right? Take a look. We have the same
Just we only copy a.
denominator.
1.
And we add numerators. 1,
1 plus 2. 1 plus 2.
1 plus 2.
3. Maybe we're not gonna have time, but we can use the your method, guys. Okay, now let's see it. Okay, 4 plus 1 multiplying a, right? Over
5, mister.
2a times 3. Tell me.
5 plus 5 times 8. 4 plus 1 equals 5.
Gosh, it's 5. Yeah, this is 5, guys. Okay, this is 5a. Okay, we can cancel. Thank you very much. Okay, I'm doing it.
Cancel the a's.
A.
And the answer is 5 over 2 times